So we've been looking at the 6 mountains. We see that 4 increase in height. 1, Mount Narayana, does not shrink or grow. And Mount Mitchell is the one that is shrinking. So we're trying to get down to why is it shrinking? Like what's going on there that's different from the other 5 mountains. So we're going to take a look at that today. If we look at things that happen on the Earth, we see that we have rocks that kind of get holes worn through them, and water kind of goes down and makes valleys and creeks and that. If we're down by the ocean, we can see rocks being worn away. So one of the big things is we have erosion happening on these rocks, which can also make land kind of change. So we're going to see what happens here. So we're kind of thinking right now maybe erosion is the process that's working on Mount Mitchell to make it shrink. And so what I'd like you to do is take a break from this video, and there is a video to watch in Schoology. So watch that one. It's about weathering, which is breaking down rock, erosion, which is carrying rock parts away, like sand and smaller rocks away, and also deposition, which is making those pieces be deposited someplace else. So go watch that movie and then come back to this video. Okay, so you've watched the video, and we want to find out what's going on with this erosion. So we're going to take a look at a reading passage here. We're going to take a look at a reading passage about erosion rates. So a rate is how fast something happens. So if you were in a car, your rate of speed would be how far you're going and how much time, your speed. So erosion rate is like how fast is something eroding? How much is it being worn away? So let's read through this article here. So we have erosion rates. There are many things that can wear down or break up land over time. Some of these are running water, glaciers, waves, wind, and gravity. You saw some of those in the video. Each of these can interact with the materials on and sometimes just below the surface to wear down the land. Look at the image below. As water is moving over or just under the surface of the land, it can pick up loose materials and carry them to another part of the stream or river. You may have seen this happen in a drainage ditch, a river, or a stream in the past. And how does water moving around you change the landscape over time? So, if you go to the beach, the sand keeps changing. If you're around Ellicott Creek, come back, in a couple months and something might be different. Maybe part of the bank is worn away. So water changes things over time. So we're going to take a little break here. We got 2 questions. So how will the water in this river, in this picture here, and the waterfall affect the land around it over time? So the waterfall might change height. If the water keeps wearing away at this rock ledge where the cursor is, it's going to make that lower. This area up front might get worn down. It might wear out on the side, so it might wear away some of the rock wall and make this a wider area. Some of the rocks that are over here are going to get broken down, and this water will carry those stones further down. And the second question is, what if the river were to move faster? So if it moves faster, we got a little more force. It might move things farther. It might be able to carry bigger rocks better than a slow-moving creek. Like it's got more force. And if the river had more water in it, probably would have more force to be able to carry these bigger rocks again. When scientists want to figure out how these different erosion processes affect the surface of Earth, they collect data about each of them for a specific location. Then they compile the data they have for each process to determine the overall effects on the land from all the erosion processes happening at that location. After compiling all this data together, they get a number that represents the rate that erosion is wearing down the land in a specific location or area over time. This is called the erosion rate. So how fast is erosion happening? After examining multiple locations and conducting tests and simulations, scientists have determined that 2 of the biggest contributors to erosion are wind and water. So there might be other things that help erosion happen, but the 2 biggest ones are wind and water. Let's read on to consider the roles of these 2 larger erosional processes on erosion rate and learn more about how erosion rate is determined by scientists. Let's think about this for a minute by using this image of the mountain above. So looking at this picture right here. In the picture you can see that there are glaciers on these mountains, and I'm going over the glaciers with my cursor. You can see where they are. So it's this big area right here and up in here too. Glaciers are large, slow-moving rivers made of ice that travel very slowly and flow over the land over long periods of time. One of the glaciers in this picture looks like a curvy line down the mountain that almost reaches a lake. So they're talking about this guy right here. So it's kind of curving back and forth, and just about makes it to the lake, but it doesn't get there. If air temperature increases, what do you think will happen to the glacier with a higher air temperature over time? So this is ice. If it warms up, it's going to melt. And that's what they say. It will slowly begin to melt. And as the glacier melts the liquid, water flows down the mountain until it reaches the lake. As the water flows down the mountain, it picks up loose material like rocks and sediments, which is erosion, carrying that. So remember, this is taking. So the taking of things is the erosion part. Breaking is the weathering, and dropping it is the deposition. So we've got the erosion happening where it picks up loose material like rocks and sediments and so forth, and carries these with it until it reaches the lake where these sediments get deposited. So the rocks that used to be up here are broken down and then deposited in the low areas. Question 3. If this continues to happen for a long period of time, what do you expect to see happening to the area where the water is moving across the landscape? Okay, so we probably would see maybe deeper valleys, wider valleys, it's being worn away. Maybe some of this is shrinking at the top because some of this rock is actually coming down. Question 4, what do you expect to see happening where the water reaches the lake? It might be getting shallower because the sediment from up here is actually getting deposited in the lake, so this might actually get shallower. Glaciers also shift and move as they are pulled down the mountain by gravity, dragging with it any rocks or soil in its path. So another question, if the glacier continues to melt and move over an extended period of time, what would you expect to see happen to the mountain where the glacier is? Okay, so we would probably see it getting smaller, maybe wider valleys, kind of like we talked about before. For this case of ice or solid water moving across a mountain, if scientists want to determine the rate this mountain is being eroded over time, they would collect the data about the glacier melting and moving over time, including first how much the glacier melts, how fast the glacier is moving, how heavy the glacier is, how much deeper the lake gets, and how much sediment or rocks get deposited in the lake. So they're going to be studying that, and it's not going to be for a day. They'll probably do this for a couple years, maybe even decades, to find out what's going on. They would then put all these numbers together to figure out how much the mountain is being worn down or eroded over time, and report this as a rate in millimeters per year. In other words, the rate, or the number they report, is how many millimeters in a year the mountain or land is decreasing over time. And they're telling us here the erosion rate for Mount Everest is 9.3 millimeters per year. This means that the mountain is eroded or worn down 9.3 millimeters per year. That's just under 1 centimeter, so almost a centimeter. And it says if the erosion rate of Mount Everest is 9.3 centimeters per year, how is it possible that Mount Everest is still increasing in elevation? Remember, it's at a plate boundary, so the plates are still pushing it up. So maybe it's getting pushed up more than erosion is wearing it down. We'll have to check that out. The erosion rate for Mount Mitchell in the Appalachian Mountains is 5 millimeters per 1,000 years. So we can tell that these numbers are different. They're both in millimeters, but one is looking at 1 year, one is looking at a 1,000-year time period. So this is about 1 millimeter per every 200 years. So we want to break it down to that. And we calculate it's like 0.005 millimeters per year compared to 9.3. So Mount Everest is actually being eroded a lot faster. 9.3 millimeters per year whereas Mount Mitchell is getting worn down at 0.005 millimeters per year. So Mount Everest is actually getting worn down faster than Mount Mitchell, which kind of is confusing because Mount Mitchell is shrinking and Mount Everest is growing. So we're going to take a look at that next class and find out what's really going on here.